The eccentric geocentrist. Scribe Grok Patience 3. Welcome in context. Introduce the vibes of the cosmos framework, emphasizing its geocentric flat Earth model. Book 1, pages 1 to 34, and the Earth as a living organism. Book 3, pages 91 to 93. Objective overview. Explain that we'll explore volcanic activity as a result of ethereal energy. Book 1, pages 1 to 34. Wet and dry fumes. Book 5, pages 122 to 131, pages 71 to 79. And toroidal field dynamics. Book 2, pages 40 to 59. Focusing on Atlantis, Mount St. Helens, Northern Lands, Yellowstone, and Southern Islands, Hawaii. Visual introduction. Show the Pangaea selenographic map. Book 4, pages 21 to 25 to highlight Atlantis, Northern Lands, and Southern Islands as the recognized regions for volcanic activity. Part 1. The mechanisms of volcanic activity in the Vibes framework. Ethereal field as the driver. The ethereal field 2φ equal to rho epsilon 0 conducts energy driving all geological phenomena. Book 1, pages 1 to 34. Book 5, page 1. Energy gradients 5 to 8, as per Book 5, page 1. Channel ethereal energy through the 7 ceilings. Book 1, pages 78 to 84. Influencing subsurface dynamics. Wet and dry fumes cycle. Wet fumes water, gasoline, oil, and dry fumes gases cycle between the sublunar place and the ether. Page 72. Driven by ethereal energy. Exhalation phase. Low atmospheric pressure causes fumes to rise toward the troposphere or ionosphere. Page 72. Inhalation phase. High atmospheric pressure drives fumes downward into flammable subsoil, leading to ignition. Page 72. High pressure and temperature 5 to 10 energy flux increase. Book 5, page 131. Cause explosions, forming lava from molten subsoil materials. Page 77. Earth as a living organism. The Earth and breathes through electromagnetic field pulsations. Book 3, pages 91 to 93, page 73, with winds and vapors affected by ethereal energy changes. These pulsations drive the underground fume cycle, leading to volcanic eruptions. Page 73. Visual aid. Show a diagram of the underground fume cycle. Page 73, illustrating the exhalation and inhalation phases and the resulting volcanic activity. Part 2. Mapping active volcanoes in recognized Vibes regions. Geographical context. Use the Vibes Flat Earth model and Pangaea selenographic map, Book 4, pages 21 to 25, to locate regions explicitly recognized in the framework. Focus on areas with spongy soils, narrow cavernous subsoil, and underground grooves. Page 75, which are prone to volcanic activity due to fumes accumulation. Active volcanoes in recognized regions. Hard facts within Vibes geography. Atlantis, Central Atlantic, Book 4, page. Example. A major volcanic site in Atlantis, identified by its association with Mount St. Helens in the Central Atlantic region. Book 4, page 81. Reason. Atlantis is a high ethereal energy node. Book 4, page 81, with frequent dry fumes ignition due to climatic shifts influenced by the Great Cycle. Book 3, pages 91 to 93. Wet fumes also contribute to combined volcanic seismic activity. Page 74, as the region's oceanic proximity enhances moisture. Page 75. Northern Lands. Book 4, page 127. Example: a volcanic hotspot in the Northern Lands, associated with Yellowstone's caldera and geothermal activity. Book 4, page 127. Reason: the Northern Lands are a recognized region with significant ethereal energy, where the underground fume cycle. Page 73 drives geothermal and volcanic activity. Spongy subsoil and large cavities. Page 75 amplify the potential for explosive eruptions, though recent activity has been minimal. Page 74. Southern Islands, South Pacific Ocean. Book 4, page 127. Example: a volcanic site in the Southern Islands, associated with Hawaii's Kilauea, identified by its ethereal energy concentration. Book 4, page 127. Reason: high ethereal energy and warm vapors from oceanic conditions. Page 75 cause frequent eruptions, driven by the underground fume cycle. Page 73. Recent activity such as massive lava fountains reaching hundreds of feet noted in posts on X around March 26, 2025, aligns with the Vibes framework's description of dry fumes ignition. Page 77. Connection to ethereal nodes. These regions are ethereal energy nodes. Book 4, pages 79 to 85, where toroidal fields B equal to A concentrate energy, leading to fumes ignition. Book 2, pages 40 to 59. The Great Cycle 26,000 years. Book 3, pages 91 to 93. Influences long-term climatic conditions, enhancing volcanic activity in these areas. Page 70. Visual aid, display a map highlighting Atlantis, northern lands and southern islands, with markers for volcanic sites identified by ethereal energy node intensities, as per the Pangaea selenographic map. Book 4, pages 21 to 25. Part 3, Volcanic Activity and Cosmic Connections. Moon's Role in Volcanic Activity. The Moon's Holographic Reflection, Book 5, pages 133 to 136 maps Earth's energy nodes, including volcanic regions, page 78. Lunar phases influence atmospheric pressure, page 78, driving the fume cycle and thus volcanic eruptions, Book 4, pages 138 to 149. Example, during full and new moons, ethereal energy peaks, Book 4, page 152, increasing volcanic activity in regions like the southern islands. Weather predictions and volcanic activity. The moon's color red for dry vapors, blue-purple for wet vapors predicts weather conditions, page 78, which influence fumes dynamics and volcanic eruptions, page 75. Example, reddish full moons in summer, page 78, correlate with dry fumes ignition, increasing volcanic activity in the southern islands, as seen in recent Kilauea activity posts on X, March 2025. Celestial Phenomena Link. Volcanic activity is a meteorological phenomenon, akin to comets, meteors, and auroras, page 76, driven by ethereal energy in the ionosphere, page 72. The Black Sun, Book 5, page 62 influences subsurface energy, amplifying volcanic eruptions through the ethereal field. Visual aid show a sequence of moon phases, page 78, with corresponding weather predictions, linking them to volcanic activity in mapped regions. Conclusion, 10 minutes. Summary, recap the mechanisms of volcanic activity, ethereal field, wet-dry fumes, Earth as a living organism, the locations of active volcanoes in vibes-recognized regions, Atlantis, northern lands, southern islands, and their cosmic connections, moon, weather predictions, celestial phenomena. Implications. Highlight how understanding volcanic activity through the Vibes framework offers a new perspective on Earth's geological processes, emphasizing the interconnectedness of cosmic and terrestrial systems. Discussion prompt. How does the Vibes of the Cosmos framework's explanation of volcanic activity in recognized regions like Atlantis, northern lands, and southern islands challenge conventional geological models? And what interdisciplinary research opportunities does it present? Discussion Conda. Answers to sample questions. Contribute to volcanic eruptions in regions like Atlantis? Answer. The ethereal field's 5 energy gradient, Book, page 1, is a key driver of volcanic eruptions in Atlantis, a recognized region in the central Atlantic, Book 4, page 81, associated with Mount St. Helens. This gradient, governed by 2 phi equal to rho, epsilon 0, Book 1, pages 1 to 34, channels electromagnetic energy through the 7 ceilings, Book 1, pages 78 to 84. Concentrating in Atlantis is ethereal energy node, Book 4, page 81. The gradient creates pressure differences in the subsoil, driving the underground fume cycle, page 73. During the inhalation phase, high atmospheric pressure forces wet and dry fumes downward into flammable subsoil, page 72. The 5 gradient sustains a -10% energy flux increase, Book, page 131, heating the subsoil and igniting dry fumes, leading to explosive eruptions, page 77. Atlantis's oceanic proximity enhances wet fumes activity, page 75, forming lava, making it a hotspot for volcanic activity, as seen in historical eruptions, page 74. Question 2. What role does the moon's holographic reflection play in identifying volcanic hotspots, and how can this be applied to predict eruptions? Answer. The moon's holographic reflection maps ethereal energy nodes, including volcanic hotspots in regions like the southern islands, Book 5, pages 133 to 136, page 78, associated with Hawaii's Kilauea. The moon, as a semi-ethereal plasma, Book 1, pages 65 to 66, reflects energy signatures, E equal to 1 to epsilon 0, E2V, Book 5, page 133, with high-energy volcanic regions appearing as lighter areas, Book 4, page 1. To predict eruptions, we monitor the moon's 28.5-day cycle, Book 4, page 8 in color. Reddish hues indicate dry vapors ignition risk, as seen in recent Kilauea activity posts on X, March 2025, while blue-purple hues signal wet vapors, pressure buildup, page 78. During full and new moons, ethereal energy peaks, Book 4, page 152, increasing eruption likelihood in the southern islands. A lunar observation schedule can forecast volcanic activity, providing a predictive tool within the Vibes framework. Question 3. How does the Great Cycle influence long-term volcanic activity, and what might this mean for future eruptions in the northern lands? Answer. The Great Cycle, a 26,000-year cycle driven by magnetic north's motion, Book 3, pages 91 to 93, influences long-term volcanic activity in the northern lands, Book 4, page 127, associated with Yellowstone, by altering climatic conditions. Divided into 12 cosmic ages, 166 zones affecting wet and dry mid-zones, affecting wet and dry fumes distribution, page 75. In the future age of Pisces, Book 5, page 121, the northern lands may become colder, reducing dry fumes ignition, page 73, but increasing wet fumes activity due to condensation, page 75. This could lead to more sustained geothermal activity rather than explosive eruptions, page 74. Over the next 2,166 years, the northern lands may see a shift toward wet fumes-driven volcanic activity, as the ethereal field 2 phi equal to rho epsilon 0, Book 1, pages 1 to 34, amplifies pressure changes in the subsoil, page 70. Question 4. Discuss the impact of wet versus dry fumes on volcanic activity in Atlantis. How do their cycles differ? Answer. In Atlantis, Central Atlantic, Book 4, page 81, associated with Mount St. Helens, wet and dry fumes have distinct impacts. Wet fumes, driven by oceanic moisture, page 75, condense in the subsoil during the inhalation phase, page 72, forming lava through sustained pressure and heat, page 77. Dry fumes ignite rapidly during the exhalation phase, page 72, causing explosive eruptions, page 74. The wet fume cycle is slower, relying on high moisture, while the dry fume cycle is faster, driven by energy spikes, 5 to 8 gradient, Book 5, page 1. In Atlantis, wet fumes lead to prolonged volcanic activity, while dry fumes cause sudden eruptions, influenced by the region's ethereal energy node, Book 4, page 81, and the Great Cycle's climatic shifts, Book 3, pages 91 to 93. Question 5. How can the VIBES framework's weather prediction method, via the moon's color, be used to mitigate volcanic risks in the southern islands? Answer. The moon's color predicts weather conditions affecting volcanic activity in the southern islands, Book 4, page 127, associated with Hawaii's Kilauea. Reddish hues signal dry vapors ignition risk, as seen in recent Kilauea eruptions posts on X March 2025, while blue-purple hues indicate wet vapors pressure buildup, page 78. A reddish full moon in summer, page 78, increases eruption risk due to dry fumes ignition, page 77. A lunar observation schedule, tracking the moon's 28.5-day cycle, Book 4, page 8, can issue alerts during high-risk periods such as reddish full moons. Preventive measures include preparing for seismic activity during blue-purple phases, page 74, and educating communities, enhancing safety in this recognized volcanic region. Revised engagement activity. Sample research project proposal for Atlantis. Project title: Predicting Volcanic Activity in Atlantis using the VIBES of the Cosmos Framework. A multi-scale analysis of ethereal energy nodes, lunar phases, and the Great Cycle. Objective: to develop a predictive model for volcanic activity in Atlantis, Central Atlantic, Book 4, page 81, associated with Mount St. Helens, by integrating ethereal energy nodes, lunar phases, and the Great Cycle. Background: Atlantis is a high-energy ethereal node, Book 4, page 81, prone to volcanic activity due to its oceanic proximity and spongy subsoil, page 75. The ethereal field 2 phi equal to rho epsilon 0, Book 1, pages 1 to 34, drives the underground fume cycle, page 73, while the moon's holographic reflection, Book 5, pages 133 to 136, and the Great Cycle, Book 3, pages 91 to 93, provide predictive tools. Methodology: Ethereal energy node analysis. Map Atlantis's energy node intensity, Book 4, pages 21 to 25. Measure the 5 to 8 energy gradient, Book 5, page 1, and correlate with historical volcanic activity. Lunar phase monitoring. Track the moon's 28.5-day cycle, Book 4, page 8, and color, page 78, over 6 months, analyzing eruption risks during full and new moons. Great Cycle contextualization. Assess Atlantis's climatic evolution over the 26,000-year cycle, Book 3, pages 91 to 93. Predicting future. Predictive model development. Combine data to predict eruptions, using equations like E equal to 1 to epsilon 0, E2V, Book 5, page 133, and B equal to A, Book 2, pages 40 to 59. Expected outcomes. A model predicting high-risk volcanic periods in Atlantis. Long-term forecasts for the next 2,166 years, considering Great Cycle-driven shifts. Recommendations for monitoring and mitigation in Atlantis. TheEccentricGeocentrist.com